Okay, and so yeah, that's partially my fault, but if you'd remembered, hey, the x and y switch, you'd be good, right?
Yeah.
Which is what this question was all about, right? What do we mean when functions are inverse of each other? One, they're a reflection across y equals x, so the inputs and the outputs switch, right? The other thing is, if you keep in mind what 3D and 4 were all about, that inverse functions completely cancel each other out, right? So g of f of x equals x. Those were both of the details I was looking for
I
there.
think they don't matter. You have put question marks. I think they cancel each other out mathematically.
So questions mark are, what do you mean by that? Go into more detail on that. And one of the things to keep in mind is when they cancel each other out perfectly, one, what we're saying is g of f of x equals x. And two, they have all of the inverse operations and in the inverse order, right? So like if you have x squared plus 3, the inverse of that is going to have to be the x minus 3 and then the square root. So instead of the square first, the square root's last. And the plus 3 that was last is now first, right? So all of those inverse operations are in an inverse order. That's why they cancel each other out.
So if this was to be on the test, and they said explain what inverses are, what would be like good?
Well, there's two parts to it. One, inverse functions are reflections across y equals x, so the inputs and outputs switch.
So what would they give us right there?
4.5. Because that's a lot of the really important details, but it is missing the really important detail as well that inverse functions cancel each other out. So that g of f of x equals x. That would probably be a 5.5. That's almost perfect. The only detail that's missing, right, is that the inverse operations, they have inverse operations of each other and in an inverse order, right? So if there's multiplication, there's going to be division in the inverse, right? And the order matters as well.
I didn't put that second one, so I
Okay, so I did a 5. So the first one I let you have 5. Really should have been a 4.5, but yeah. Number 7 should have been very straightforward. What do we mean by a logarithm? What is a logarithm? An exponent, right? So like if you had just said, hey, a logarithm is an exponent, so log base 4 of 36.7538 is approximately 2.6, means that 4 raised to the 2.6 is approximately 36.7538. Right? It needs that extra detail that I said but didn't write down, but a logarithm is an exponent. So this statement means that 4 to the 2.6 is approximately 36.7538.
If we just wrote the equation, would you give it to us?
It would earn you credit, but like one, you had to clearly address what a logarithm is. I don't know.
Base raised to the exponent equals approximately.
And so you could say something like that, base raised to the exponent is equal to the argument, things like that. Did I ever tell you where the term argument comes from? Because I finally looked it up.
Let's talk about it.
All an argument is, so an argument is not only with logarithms, arguments are just the input for an operation. That's it. So like, y'all may not have done a lot with it, but with trig, right, the sine of an angle, that angle would be the argument for the sine, right? It's the input for sine. That's all an argument is. No, can't stand them things. Well, if you take pre-cal, you better get real comfy real quick.
Sine, cosine,
Because, you know, we were supposed to cover it this year, and we didn't have time.
Oh, I didn't take the pre-cal. You need to order me. I'm done with my high school now.
Yeah, we talked about that. I forgot. You're wrong, but
No, I'm not.
you're literally taking pre-cal just at Shelton next year.
Oh, you talking about math 101? Yeah, I ain't even thinking about it.
Wait, you're saying 101?
No.
112?
Yeah, 112.
That is pre-cal. Oh, dang.
You gotta study. Nah, I gotta take, next year I'm taking Bio 101, English 101. My first, like, that's how I'm taking.
Okay.
You gotta study.
Yeah, I'm looking for it. It's right back there on my desk. Alright. So, in the textbook, now we got 50 minutes to learn as much about logarithms and exponentials as possible.
50.
We filled this table out, right? What's your textbook? Please get it out, thanks sir. What's your textbook?
I'm actually don't have any. We'll get it tomorrow.
Last day, dude. Come on,
Oh,
bro.
that's right, we did talk about this. I mean, we're testing on Monday.
That's the last
I
day.
told you I probably gonna bring it though.
Okay, well, write your stuff down on the blank paper. I forgot that's why you got blank paper. Xavier, you got your textbook? Good. So, we want to be on page, not that, that's volume 1, bro.
I'll make that away.
No, don't throw it away.
I don't need it.
So, 171, 172. And what we're going to focus on here is actually,
You need to put a lot of these on test too.
yeah,
Don't.
better not screw them up then. So what we're going to look at here is activity 1.1 to get us started on some of the basic ideas of solving a logarithmic equation. And so, for example, if I look at A, what we're trying to do is arrange the given terms to create a true logarithmic equation. So I need a logarithm, I need a base, I need an argument, and I need an exponent using these numbers. What base would I use?
7.
So log base 7.
The
2.
argument be
Raise to
49.
2
The argument's 49.
equals 49.
No, babe. It's 49. That's the argument.
Yeah, that's right. 49 equals 2.
Because remember, what is a logarithm? It is an exponent. Now, if you want to, could you have done 7 squared equals 49 to help you get to this logarithm? 100%, right? But notice what we always want to keep in mind, because students in first block were again forgetting this already. When I look at a logarithm, I'm taking I'm taking the logarithm of what the output was from the exponential equation, and it's equal to an exponent. But the bases always stay the same. The exponent is what it's equal to, and the output becomes the input, right? The argument, the input, is what we got out from the exponential. So let's work with it together to try to get B, C, and D. Check in with each other. Let's hear some discussion, and let's get to work.
Let's do C. Let's jump on C.
I got B already.
Well, C, I just, C would be,
B is the log. Subscript is 6. The argument is 264. That's 6. The argument is 1 over 260.
for C, I put log 1 to the 4 equals 4. That's what I got for C. Log 1 to the 4 equals 4.
Caleb, I need you to work on your language. Listen, it's not all Mr. Kinney. You're getting things wrong because you're misunderstanding this. First off, it's not log base 1 to the 4th. It is a base 1. That's not an exponent. It's the log base of something of the argument equals an exponent. But I want y'all to think about it. Do y'all agree with Caleb's equation?
1 raised to the 4 is,
So 4, you raise the log just the way.
yeah, 1 to the 4. So you would switch it around.
4
4,
raised.
log base 4 of 1 equals 4.
Log base 4 of 1.
equals 4.
What are you, bro?
So 4 to the 4th is equal to 1?
What are you talking about?
Wait,
4 to the 4 would be 2. It's 6.
but you gotta use
I think
these
it's 4
numbers though.
log base 1.
Let me ask you this. What is the exponential that we could write here? The base would have to be what? 4. What would the exponent be? 1 is equal to 4. Remember, Caleb, that's your exponent. And what is a logarithm?
1 to the 4th is 1.
So it'd be log base 4 of 4. The output from the exponential, that's the argument, the input for the logarithm.
I had equals 1 at first.
Okay.
Okay, but you didn't for any of the times that you told me, right? pay attention, be careful, and pay attention to your language on that. Xavier, how's this going for you? You done? Good talk. Thanks. Do we need to talk about any of these? Okay. So one thing I do want to point out, just because I know Keyshawn was struggling with this a little bit, Preston got this one pretty quickly. You said log base 6 of 1 divided by 216 is equal to -3. How'd you get there? Okay, so one, don't just put it in the calculator, you need to explain it.
Subscript
Uh-huh.
with the exponent.
So you did 6 raised to the -3 is equal to 1 divided by 216. So two things I want to point out about this, because this would have helped you a lot. Remember, a positive exponent is repeated what?
Multiplication.
A positive exponent is repeated multiplication, right? 7 times 7 equals 49. So what is a negative exponent? Repeated division. So the fact that I had 1 divided by 216 told me I had to have a negative exponent. Does that make sense? So those are the things that we want to consider and pay attention to, that a negative exponent is that repeated division.
B is log base 4 of 256 equals 4.
Do y'all agree? You all agree? So I'm jumping to number 3, so we get some more practice with this, and so I can show you a couple of things. I'm going to give you, let's say, 5 minutes to knock out as many of these as possible, and then we'll discuss. Because I just want to see what you're going to do on your own. Just talk with each other. When you get stumped, ask questions of each other, and I'll listen in on conversations to know what to discuss later. All right?
When you said the log was even with the other number, what does that mean? Just the argument?
It's the logarithm of the argument, right? So the argument is in line with the log, so you know what the argument is. It's not an exponent. It's in line with.
8 is log base 8 of 64 equals 2. We do the exponent of 2 with 8, it comes to 64.
So 8 squared equals 64.
Yeah.
So that's something we would want to notice. Everyone agree with that? Caleb, if you think about how to do this strategically rather than guessing and checking, you'll learn some more important information. Let me ask you all a question. Is there a way to rewrite the logarithms so that it might be easier to solve for the variables in some cases? What way could you rewrite it? Okay, let me reword the question. How did you write some of the equations on the previous problem to help you figure out the logarithm? So, as an exponential? Could you rewrite some of these as exponentials to help you figure out the answers or figure out what the variable is equal to? That might be something to consider. It will help definitely with several of these. Right, Xavier?
We can move out right, like, the board is exponential.
That's a good question.
Raised to something.
Log 9 of 27 equals 30.
It's not.
Alright.
It's log base 3 raised to negative 3 raised to 1. That we talking.
Say that one more time.
Log base negative 3 raised to
Which one are you looking at?
1. Talk deep.
D? No. I would, like, let's talk about, let's actually talk about D. Does anyone, one issue that y'all are gonna have with D is what's the base and what's the argument for D?
-3 argument.
The base is what? 10.
Natural
Not natural log.
common.
Remember, natural log is ln, and that is log base E. Is that Xavier just moaning? But if it's no base written, that's known as the common log, which is base 10. So what I mean by my earlier statement is I could rewrite that as an exponential. What's the base for the exponential? Or I can write it as a power would be what better way to say it. What's the base? Huh? 10 is the base. What's the exponent? -3, and that's equal to the argument of n. See? Say that one more time? There you go. Because remember, it's repeated division. It's 1 divided by 3/10 being multiplied.
Would you not put log 10 or it's known as log anyway?
Remember, I took the logarithm and I rewrote it as an exponential, right? So there are different forms. I'm going to talk about how to use inverses in a second, but that is an important thing to notice, that you can just rewrite it as an exponential to help you figure out what the variable is. Xavier, sometimes I wish you took your academics as seriously as you do trying to be funny. Not necessarily succeeding, but trying.
I do take it serious. I'm just trying to figure out. Alright, so number for B, what y'all did?
9 raised to the what equals 27.
That's a good way to think about it. I will say this. It's not an integer exponent for f.
Yeah, I know it's a decimal or something. I don't know.
Not necessarily. But have y'all done B yet?
Mm-hmm.
Yeah?
Would be 4 raised to -2 equals 116.
So you're saying, so you rewrote this one as 4 to the -2 is equal to 1 divided by 16. So what is n? 4. Looking at B.
Oh,
How'd you get to that 4 though? You just guess and check?
What?
see, I put 8, so I said
I
I
thought
said
about-
4 from the start.
That's not about, I was thinking of 4 times something, no, a 16 divided by a negative, 16 divided by 2. So I thought about it like that, 16 divided by 2. I guess you.
I have no clue how you got there. Let's break B down then. Log
You're not
base
gonna make us
n.
write it out and word on how we got it in text. Like, can we just do it, please? Like, come on.
That's
You
your.
ain't-
Come on,
you
Mr.
ain't
King.
got-
I
ain't
need
gotta
you
do
to
it
understand
like
you
that.
got 2 more days where you have to justify for me. Get over it. Alright.
One more day.
Today and Monday.
No.
Alright.
Monday.
So, first off, how could I rewrite this equation? There's 2 ways that we could do this. One, I could just rewrite it as an exponential.
One divided by 16 raised to the n. No.
So 1 divided by 16 raised to the n? Do y'all agree?
That's not right.
No? Remember, the base of the logarithm,
N raised to 2.
N
Right.
raised
Equals 1 divided by 16.
now you can actually do it very easily from here if you remember one detail. What is a negative exponent? Division. So instead of writing as n to the -2, I might write this as 1 divided by,
Negative 16.
say again?
Two negative 2s.
It's, so if it was 3 to the -2, that would be 1 divided by what?
1 divided by, no, 1 times.
Negative 6.
-2. Oh.
Negative 9.
1 times 2.
Negative
Raised to
26.
-2.
Remember, that negative is telling me to divide, that's telling me how many times to
Negative.
divide what?
3.
3. So I'm dividing by 2
divided by-
3s.
Yeah. He just said that. He literally just said that.
He did it.
Yes, he did.
Thank you, Preston.
He said sometimes some.
I said
He did, yeah.
He said 2
He said the 2 2s. It's not 2 2s, it is 2 3s. So if it's n to the negative 2, I'm dividing by what? Twice.
N.
Notice n times n is just n squared. Once you divide, the negative gets dropped off. So do you know what n squared is equal to? Because I do.
4.
N squared.
N.
What square equals what? What did you say?
What is n squared equal
Can't do
to?
N on here.
16.
16, guys. For these two things to equal, the ones are the same, the n squareds have to be the
So where
same.
did he get 4 from?
Well, what would you do now to solve?
Oh, okay. Take square root.
Uh-huh. So what is n equal to?
4.
Anything else?
Oh, plus or minus 4.
So we need to remember 4 and negative 4. Now I will point out though, we have talked about this in the past, can the base of a logarithm be negative?
No.
Remember, the base of an exponential can't be negative, right? Negative 4 to the negative 2, we can't do that. You can't have a negative base. So you just need to recognize that that doesn't work, and the only one that does is the 4.
Not the E.
Want to look at E together?
Yeah,
Okay. So log base n, and I'm going to show you a slightly different strategy here. So we rewrote it as an exponential last time, but I will also remind you, what's the inverse of a logarithm? Remember, L.
Exponential.
Okay, just in general, it's an exponential. Remember, e raised to a power is the inverse of a natural log because they are both base e. But the inverse of a logarithm is just an exponential. So I'm going to make this my exponent. What does the base need to be for the exponential though? So they cancel each other out. Remember, they have to have the same base, right? And so those are now canceled, and so the cube root of 49 would equal what?
Oh, you said the cube root?
Because it's still, because those cancel, so the cube root of 49 is equal to something. You can't put that, don't put it in the calculator. Yeah, because you don't want that. Look at the board again. What am I forgetting?
Oh, 2 or 3.
But it's the cube root of 49 equal to 2/3? You just typed it into the calculator.
You still gotta put it down though.
Something I'm missing. Look, there's something I'm missing from this step.
3, put the N over there, or 2 over 3 N.
Not 2 divided by 3.
Right, 2
Remember,
divided by 3 times.
I would say, I made this the exponent, right? So it's n raised to this. So this needs to become a what?
X1.
With what base? An exponential expression is that inverse of a logarithm. And so I have to do n raised to that logarithm for those to cancel, and so I have to do n raised to that exponent.
So that 3 cancel out?
Kind of. If you remember, we did talk about these kind of exponents before. Does anyone remember what this is telling me, the denominator? It's telling me about the root.
Yeah, I think.
So this is a
Cube.
cube root of n squared. That's what it means.
Yeah, that's what I was talking about, that eight counts.
You see how that? So that's what we mean when we say n to the 2/3. That's a cube root of n squared. The numerator is the actual exponent, the denominator is the root. And yeah, the cube roots would cancel in the sense that if I cube one side, I have to cube the other, and they just naturally cancel out. So 49 is equal to n squared. Square root.
7. Plus minus 7.
Could it be a positive or a negative? Remember, it's the base of a logarithm, right? Technically, we would want to put the plus and the minus, but it is the base of a logarithm, so I'd cancel this one out, and I'd be left with only n equals 7. Alright, so base of log cannot equal negative. Or you could say base of log is greater than 0.
Somebody's
So
gonna.
I hope we ain't gotta do that on test.
Yeah, you need to put some, no, you do need to put some weight on it.
It's supposed to be this.
No more than one.
Yeah,
It wouldn't be many.
You talking about one of them, like them right there?
Mm-hmm. I haven't decided yet.
The one like this, if you miss, you miss one thing on the test, you do like 3 of these.
So I'll point this out. If you pay attention to this part here, it's actually fairly easy for F. Well, for one, the variable's already on its own.
I said 9.
So can you put it in the calculator? You don't have to do anything else. If you put it in the calculator, n is equal to what?
7 point something. Not 7
No.
point something.
And is equal to log 9.
Base 9 of 27, but what is log base 9 of
I
27?
did 27 raised to the 9.
No, you don't.
It should be 9 raised to n. It's 27.
It is, but what I'm pointing out is the variable is already on its own. You can just put that in the calculator.
No, 927. 1.5.
Okay.
Man, you gotta put something on. You got to. You got to.
What about 10 on it?
Okay. Now you would want to justify this.
Oh, dang it.
Why is n 1.5?
Cause 1.5.
9 raised to the
Yeah,
1.5
it's
is
27.
27.
That's all. That's what I said. What 9 raised to the 8 is 27.
I know. I didn't say you were wrong then when you said that. But I will point this out. You could have worked this out without just using the calculator. This would show me greater levels of understanding. And Preston and Caleb hinted at this, right? 9 to the n is equal to 27. Can you rewrite 9 and 27 so they have the same base?
Yeah.
Like a base raised to a power? 9 is 3 squared. 27 is 3 to the third. So 3 to the 2n is equal to 3 to the third. Well, I can just now take the log base 3 of both sides.
Yeah, that's no different.
Alright, I got C.
You losing my interest right
I got C. C and F or C.
Okay, what is 3 divided by 2?
there. 1.5.
Okay. That's greater levels of understanding though.
I know.
I'm not gonna stick to the calculator.
Yeah.
Well, then you're not going to score great.
Yeah.
It's not showing great
And
mastery.
you write it out. Write it out.
Maybe I'll just have to make it with just variables so you have to really explain it and understand it.
Miss Kitty, I swear.
Yeah? So what if I told you log base x of x to the 7th? What does that equal?
Wow. You do.
That's easy, let me see.
He said G.
Do it then. I'll talk your head.
You talking about it's got 2 versus 3 grand?
You big fat space rock.
What? Stop being rude.
You don't
Bill
know
is
that,
rude.
Miss Kitty.
So,
Log base x of x to the 7th.
So they made a log.
so it's log base, so we don't know what the log base is, or is it log base 2?
Log base x.
The base is X.
The base is x.
So these are the same.
Uh-huh.
These are equal to each other. They're both x.
The base of the logarithm and the base of the exponential are the same.
The argument
Mhm.
is raised to the 7. Oh, alright. I guess.
What do you mean? I don't know. If you put that on the table, it'll get a little blank. Oh, you don't put the calculator.
This is the easiest question I've given
We
you
can't put
all
it.
day today.
You can't put that in calculator.
Oh, it's x to the 7.
Not x to the 7th.
Not just be x.
Not
It's
just x.
basically 1 and then 1 to the 7. Think it like that.
No, it's 2x.
7x.
2 7.
Let me ask you a question. What is a logarithm?
Exponent.
What exponent would go on x to give me x to the 7th?
7, that's what I said. It's basically 1
What?
is the base.
Well, it's not 1 as the base, because 1 to the 7th would be 1.
Exactly. Oh,
Right? But also remember, hey, what's a logarithm and an exponential's relationship? They are what? Can I see that?
Inverses.
They're inverses. Oh, so you mean this logarithm that has the same base as the exponential would
They
just
cancel
cancel out?
Yeah.
This one's one.
So it's just 7.
You're
Oh, so you did that.
As I said,
I was doing it in my head, I ain't write it down.
it's the simplest one, isn't it? Once you understand. Alright, what time is it? 10:40.
But can I play a review game or something? You gotta make your class a little fun. A little.
let do it.
A little fun. A
like
A review game of song.
Man, it's like you think you're in elementary school, and I recognize that you're in high school.
Let's do a like Kahoot or
Miss
Quizlet.
Aubrey is one of the hardest teachers in the school, and she do review games.
Miss Hubbard is hard. She's,
Let's do a like Quizlet.
Miss Dub do review games.
And
Ask over Richard if he do review games.
I got a missed call from my cousins.
y'all are used to teachers trying to entertain you.
And
I'm used to teachers trying to raise students' expectations and to learn more.
Miss Kennedy ain't about that. It's saying like, at least let's have fun while learning. Like, do a review game so we can actually do the review, but we're having fun with it. Make it a competition. Like
That's
something at least. Like you think we just run for fun? You think we just run 24/7
I
non-stop?
run for
We
fun.
have fun with it. You gotta have fun with it.
You gotta learn how to work hard.
This is fun.
You've been laughing.
Yeah, that's because Christian is ain't funny.
Don't steal my spotlight. I'm funny. Number one, a value. Oh yeah, we need to go to this page. Just a couple pages later. Just a quick little recap of things. This is the end of that lesson. One more, couple more pages. It's after 1.3. There it is. Okay. We're not going to go over 6 or 7, but the others of these we can answer. Number one, the value of a logarithm is blank equal to the exponent of the corresponding exponential equation.
Always.
Yeah. Literally, what is a
I
logarithm?
was using always, sometimes never.
Always, sometimes, or never. Yes, sorry, I should have clarified. But always, this is probably the most important one to recognize, right? That is huge. The value of a logarithm is an exponent, right? Is always equal to an exponent. Number two, the argument of a logarithmic expression is never a negative number. I will point out it's really easy to see that if we think about, if we have an exponential function b to the x. Remember, the argument is the output of an exponential, right? The output of an exponential is always what? Positive. So the input, the argument, is always positive, right? Because the reflection of y equals x, they're always positive. Remember, what was the output becomes the input, right, for the inverse functions. So they are never negative. The value of a logarithm
Never.
is never equal to...
Sometimes.
Sometimes.
Not always.
Not always.
It's never.
It's never.
Sometimes.
Why is it sometimes?
That's a lie. Exponent can be positive.
The exponent can be positive or negative, right?
Negative is a lie.
Can I see it sometimes?
Yes. I asked a question and you changed your mind. I didn't tell you you were wrong. I just wanted the evidence. Because weirdly enough, just memorizing stuff's not going to help you because you can Google whatever.
You sure?
Yes.
And memorizing plays help.
You telling me that if you just memorize the play, you're golden? Like, you never have to adjust on the field because the defense... Are you offense or defense?
Offense.
You're offense? So the defense never does things that you have to account for and slightly change the play?
No, you memorize. You run the same route no matter what.
So
If
sometimes-
the play call changed, all you gotta do is know the next play. It's memorizing the play.